Hi, today we are going to talk about the software engineering lecture 3, the software process. And first, let's do some recap from lecture 2, where we introduce three software process models. With the first one, waterfall models, where we separate and distinct phases of specification and development. Each phase must be completed after the next phase begin. And the evolutionary model means the specific development means the specification and development are interleaved. Uh, so this one maybe I should take more interest why the specification and the development are interleaved, because from because from my perspective, the evolutionary model is building more prototypes, and there are two kinds of ways to do the evolutionary development. If the customers knows very well about their requirements, we can do the prototype throwaway to we can do the
systems development.
We can do the uh, sorry, I think it's a prototype throwaway, and the other one we can do the other one we can do uh, the other one we can do the exploratory development, and where this is one is the customer knows it well, and the second one is the customer does not know, and this one is the software knows. And additionally, we come to the formal method development, where we have the uh, mathematical system model formally transformed to an implementation, and iterative mode, where the system is built up in a series of steps. Uh, in a series of steps. In a series of steps. Maybe this one is not very clear, and maybe I should understand it. Discuss with my professor. And in this lecture, we are going to look at the reviews-oriented model and take a deep look at the software design process. So the reviews-oriented model is just that if you do not know how to write an algorithm, and you just Google it how to write this algorithm in Python, and you can reuse the module that someone has already used, maybe to serve as a building block for your project. And for example, the reuse-oriented model software incorporates with the reviews of the existing code according to your development process. Examples of reuse code may be user authentication. For example, you can use the robotic maybe check to do the web development to prevent the DDoS attack. And the encryption, you can do the maybe TLS to do the encryption, which you just review the existing code. And the GUI element, for example, you can use wix.com this to do the maybe a text box, a text input box, and a post box, something like that. And many libraries where you can do some functionality. Um, Maybe we also do some copy and paste from the web, something like that. So after building the intuition about that, we need to understand why is the reviews oriented, what is the formal definition for the reviews, formal procedure to do the reviews oriented model. The requirement specifications first are going to be defined into the two parts, where the software discovery and software evaluation. and then we need to refine this requirement to do the requirement specification. So depending on whether it is available or water available, we can configure the application system and the application system available and component available. Okay, cool. So, oh, I see. Oh, I see. So the thing is that the code reuse oriented model is that you have maybe you want to build a maybe online selling second-hand goods selling platform, and you maybe look at some existing open source software and trying to see whether it is good or not, and whether this maybe met my requirement, whether I can make it better to trying to negotiate between the existing software and the requirement, and then we are going to find the conclusions whether it's available or not. And what if we have already found some existing system, we are going to just change some parameters or change the name of this system and to just configure this application system. And for example, in the online selling platform, we have in Chinese we call them 零点校园, and this is online selling system especially for universities, so you can just configure them. And what if you can only find some component where maybe the APIs to write the GUI and the user interface, or then you can let the components, and that's the new component to integrate the system. Just it's just this one is just a part of it. This one is just a part of it, and this one is this one is and this one is no, sorry, this one is part of it, and this one is the whole system. And then we are going to talk more about the advantages and disadvantages. Where the advantages is that it's often not practical and not realistic to design the maybe code from the scratch. You cannot write from compiling assembly language to assembly language very complex, and an element with high code review suggests high quality code, which means this code is a very essential module for this project, so it must be high quality. And I mean, it is not necessary, but what if people tend to reuse your code? Then it suggests that it's a very high quality code, and yeah, and maybe the next one should reuse them because it's essential and high quality. And the code reduce can reduce your costs definitely, and the code reuse increase the product quality because the it is high quality code, and increase your lower the risk of peer failure, which is based on we have increased our product quality. And there are also some disadvantages where it can lead to some requirement compromise. For example, what if I have found an existing system and I only configure it? I will find that some functionality might not be exactly what I want. For example, from maybe the online selling second-hand goods store, we can find many website templates from the web, and they all have the account. But however, I want to do a thing just like without account. We only communicate through email within the context. This is very surprisingly different from others. And then it can lead to a loss of control some part of system where, I do not know how to change it. For example, one of my friends told me that he cannot change the email delivery maybe API within the WordPress's system, just like that. And then the software design process where we have several stages where we need to specify the requirement, design this project, and specify this requirement, design the system, implement the system, test the system, integrate the system, and evolve them. Specify them, design them, implement, test them, and integrate them, evolve them. The process model which we choose will affect how the stage interact with each other. Regardless of the process model, the stages have similar characteristics. So last lecture we talked about the specification is the most critical phases of the software engineering project, and since we have the specify. So I'm not very sure about why the process model will we choose. Will affect how the stages, regardless of the process model stages has. I see. So the process model we choose will affect how these stages interact with each other, but these stages itself has some similar characteristic. So the first thing we talk about the specified requirement, where establish what services are required and concentrate on the system operation and development using the requirement engineering process. So the requirement engineering process is defined as follows: where firstly we need the feasibility study and to generate a feasibility report, and then we come to the requirement elicitation and analyze. We have the system model, and then we have the requirement specifications. Requirement specification it's the elicitation is just trying to know maybe do the brainstorming, trying to know what you want, and the requirement specification is just maybe more specify what you want, and the validation is whether it is just like testing whether this process is indeed this requirement is indeed a requirement. So we can see that the feasibility study will generate the feasibility report. The requirement elicitation and analyze will generate the system model, and the requirement specification will generate the user and system requirements. And the requirement validation will finally generate the requirement document. So interesting, huh? Right. Why we? Yeah. I think so. So it's a system model, and it's a user and system requirements. So the thing is that you firstly have this one mostly maybe just do we have enough money or something like that, and then we do the requirement elicitation, trying to build maybe that kind of software engineering can be classified into three categories. Well, I'm not sure what are these system models we're going to use. Is it maybe product based or I don't think it is the four models we discussed. So maybe let me. And then we going to design. Design is the software we talk about in the design. I mean, before the I don't think it is the waterfall system model. It is just maybe it is a website. So it is system is just a website, and it can be online selling website, e-commerce website. So this is a kind of system. You can just categorize, make a category for them. And then based on the system model, we are going to specify the user and system requirements, where user and system requirements just like within these building blocks, what kind of requirements do you want for just to specify them. And finally, we're going to generate the requirement document. So the requirement document consists of the system model and the user and system requirements. So it depends on the requirement document will have the system model and system and user requirements. So in terms of the design part, we're going to do transforming from the specification to an executable system. Then we have two parts where it is software design and implementation. The software design is the design software structure to realize the specification. Maybe take tasks, solve to design databases, website design structure, communication protocols, and the implementation is translate this structure into executable program. The activity of design and implementation are closely related and may be interlinked. Design and implementation is closely related, and this is very important. So the design and activities of design and implementation are closely related to each other. Okay, and then it comes to the design activity. Design process. So the design implementation part and yeah. So firstly, we're going to talk about the design part. Okay. So the design part, we're going to firstly do the architectural design. So it is just separate the web service modules, the subsystem making up of the system, and the relationships are identified and documented. And the abstract specification is for each subsystem and sub-specification and its operational constraints and services that it is produced. And the abstract specification is for each subsystem, and abstract specification its operational constraints and services is produced. So, I see. So firstly we do the module, and then the first one. The first one we design the subsystem. What kind of subsystem we have, and the second one is we're going to what kind of specification on operations for. It's just like furniture. This one room. How many rooms do we have, and how to do this room. And the interface design is that for each subsystem, an ambiguous interface with other subsystems are designed to be documented. Yes. Interface, right. Because we have this is just designing a door, right? Right, designing a door. This is room, and this is a hole. Okay, interesting. And the formal specification may be used in this stage, which is an ambiguous interface with other subsystem. Right? How can we interchange with them? And then we are going to talk about the component design. It's the services are allocated to components, and the interfaces of the components are designed. the services are allocated to components, and the interfaces to these components are designed. The interfaces to that. So what is the difference between the I see. Are allocated to components and the interface to the components. And then it's data structure design. What kind of data structure going to services are allocated to components and the interfaces of the components are designed. Components services are allocated to components, and the data structure design is using system implementation are designed in detail. And then we're going to do the algorithm design. So for example, we are going to design a coffee drinks machine software. So what are the main subsystems? We have the graphical display, cash handling, accounting, safety system. The graphic design display is useful for users to use the system. The cash handling because you need the handle the dollars or the pounds. The counting that maybe the manager needed to account how much money that he earned, and the safety system is that we do not want the money to be stolen, and the recipe handling is that maybe we have the cappuccino, have the nuttel, and have the American or something, and the stock control is that we need to know, when there's not a limit, when there's not enough stock, we need to give a flag where we need to add more coffee, and then how may we define the abstract specification for each, and abstract specification for each? How do each subsystem? So how does each subsystem interact? For example, the abstract specification is how do we define the abstract specification, and this is one thing, and how do the different subsystems interact? Is this just the input of the display just how the data where how much coffee do we have, what is the unit for this coffee, and what category, and output is just some numbers on the screen, and can we define a specification for component data structure for one subsystem? Or for example, we have the accounting part where the accounting part is maybe the it's stored the data is stored in a linked list, and we can add maybe I think, for example, if I am designing the system, I may say maybe we have some ingredients in making the coffee, and I'm going to store it in a hash table, and maybe I say the coffee, the caffeine, and maybe the cocoa, that is two ingredients. How much money? I mean, let's see. Oh, I see. How many categories do we have? We have the cappuccino. We have the nuttel. and we also have the money for each unit, and each time we are going to, and we have to, and we have the orders that this coffee have, and each time we order one, this number is increasing, and finally we can command them to get the total number of money that sold through this coffee machine. This is how maybe the algorithm is just the unit price times the number of coffees is equal to the money we made, and we can subtract to the cost of this coffee. Yeah, and so the abstract simplification is, I think, it's just what are the input or what are the output are the functionality that the system does. And I'm not very sure about the component design. I'm not very sure about the component design. So what are the components here? The component is it the function within the subsystem, or I'm not very sure. So what are the, I know this one is just like building a room and just building a door, but this one is just like building a home. This is building a room. This is building a door, and this is it building a lamp, a bed? I'm not very sure. I see. And this is this. And maybe the cache handling, we have the abstraction specification that the abstraction specification is just what kind of functionality that it has. You can register the entry for new coin and update the balance. It can handle everything you can see using HeyCan, and it can be interfaces to a wide range of coin handling mechanisms. And it can interface with the node acceptor hardware, and it locks the coin mechanism when the machine is out of order. Yes, it does not allow and maybe it rejects the incorrect currency. And the model is the graphical views of views of operations or structure of the system can be dynamic or be static. And why do we have a model is that we can format the types and the formats of the required information. And it's easier to get the big picture of the text document rather than the text document. We do not heavily rely on the natural language again. This is why we call it unified modern language. Some can be translated automatically to software implementation. That's very important. We can say that see that we can use the MATLAB to draw the deep learning algorithm, and then we can automatically transport to software implementation, and it can be tested, validated automatically. Yes, I can see whether my MATLAB model is functional or not. And the development method here are a systematic approach to developing a software design. The design is usually documented as a set of graphical models where we can the design methods. Okay, the design method. And all here is the design models and the design system. Okay. I'm not very sure. Software design, and what are the models and the design method? I'm not sure what is the link between the models and what is the link. Why do we talk about models and why do we talk about the design method? The design is usually documented as a set of graphical models, and the design method not very clear for why do we talk about that. And design methods are systematic approaches to developing a software design, and we can see the design is usually documented as a set of graphical models. It may be data flow model, entity relationship, or ER diagram, entity relationship, ER diagram. Entity relationship, database or classic design, structural model and object model, the state translation diagram showing the system states and triggers. So the design is usually documented as a set of graphical models. Maybe it's data flow model from data's perspective, the entity relationship attribute model, the structural model, the object model, the state translation model, the state translation model. The state translation model. Yeah, the design is usually right. I can see the meaning that the design is documented as a set of graphical models. Then it comes to the implementation part, where we need to translating my design into a program and removing the errors from the program, and programming is usually a personal activity, no generic programming process, good programming, organizational standards, no generic programming process. I'm not very sure what that means. So programmer carry out some program testing to discover the fault in the program and remove this fault in the debugging process. So the implementation is mainly about the programming and debugging. And the good programming is iterative, where maybe you write small amount code and test it, pass it or not. If not, debug and refine it. I'm trying to archive them. And the debugging process, which is just the debugging process is just here, going to be implemented in the maybe located error, maybe it is in line 16, and the design error repair, maybe we should not use an int, and we are going to change it to flow or double, and we need to change it from here to here and retest the program. And then we are going to talk about debugging the real world. Actually, I'm not very sure about what does it at will mean. So maybe I should ask a question about that. So maybe oh sorry, I'm very surprised that it's all the same. Okay. And some software faults indicate the problems with overall software design and required application redesign. Maybe the lack of the safety. Some software indicate problem with overall software design. Usually is application redesign. Lack of the intrinsic. Does that mean that maybe, for example, previous one it only one person, but now we want the system to be more person, and I can also I can only redesign it, and I can and if the debugger hardly impossible to reproduce in the testing conditions, insert debugging codes. to reproduce it. To reproduce. The bugs are hard to reproduce in the testing condition. I think it's likely insert a debug or test code embedding a documented log to a lot of embedded into the trace statement, print them as a patch code, which will help to recover the fault condition, example caching and logging. If the bugs are hard or impossible to reproduce. Oh, I see. So if the bug is hard to reproduce in the test conditions, it's that the I'm not is that the reproduce like discover or something? If the bug is hard to discover, it's the reproduce discover. I'm not quite sure why this we think about this reproduce. And then it comes to test. The software validation is that the verification and validation is intended to show that the system confront to his specification is the verification, whether the system meets the requirement verification and meets the requirement of using customer validation. It involves check and review process. It involves check and review process and the software testing. The software testing involves executing the system with test cases that derive from the specification of the real data to be processed by the system. The system testing involves executing the system with test cases that are derived from the specification of the real data to be processed by the system. The system testing involves executing the system with test cases that derive from the specification of the real data to be processed by the system. System testing involves executing system with test cases that are derived from the specification of the real data to be processed. That's derived from the specification of the real data to be processed by the system. 这什么个意思呀？你想说个啥？我能理解这个意思，肯定有 test cases 的。Derived from the specification of the real data to be processed by the system. On the specification of the real data. Real data. So I think the thing is that we need to test the test cases derived from real data. Yeah, we need to use the real data to test the system. Okay, and the testing phase is that we need to do the unit testing, we need to do the module testing, and we need to do the subsystem testing. So the component compares the unit and the module, right? Okay, cool. This is very much more the component is the integration testing and the user testing. This one is very important. The component is the module of the subsystem. Okay, cool. And the acceptance testing, the unit testing, the module testing, the subsystem testing, the system testing, the acceptance testing, the unit testing, the subsystem testing, the system testing, the unit testing, the module testing, the subsystem testing, the system testing, and the the acceptance testing. And the first two is component testing. The third and the first one are the implement integration testing and finalize user testing. And the testing stages. So testing stages, we just mentioned before, we have the unit testing, where individual components are tested, the module testing, where it is related with the collection of dependent components are tested. The subsystem testing is merged with the third system testing, where the modules are integrated into subsystem are tested. The focus here should be on the interface testing. Oh, the subsystem and testing the emergent property, emergent module testing. I can individual components. Okay, the module, the collections of independent. I can see that the subsystem. Would you mind give me a I see that the test is about testing stages, and we have the maybe the let's see, maybe the customer and the system is with website, and the unit testing. Unit testing is maybe the email. I think it is an subsystem module. I'm not very sure why it is the interface testing and testing emergence and right. Let's see. And I think it's just the module. The module is system is the website. The subsystem is maybe the user interface and maybe the email transforming and the I think so. The module testing is that it is the I think it is just the email or WooCommerce in the WordPress, and the unit testing is just like the maybe one line of code within this component. I think it's just maybe just a small collection, a series of codes, maybe as a component. And I see, this is much more clear, for it can be mapped to the object-oriented programming, where the unit testing is just like the method level. Okay, just the testing an individual method, and module testing is I think it's interleaved with unit testing. Okay, with testing which integrate with the testing classes which integrated with other classes. Subsystem testing is a number for the for example, card payment services, SMG, message sending services. Okay, a number of classes, testing classes, which are integrated with other classes. Yeah, it may be a classes. It's maybe a collection or okay, cool. You can maybe is there a higher level? Is there a collection of is there a concept for collection of collection? And the subsystem testing and the system testing, just like the whole system, and the design phase is just like where we integrate them into a much more detailed one, where we from the requirement specification, system design, detailed design, and module. I mean, it's just like It is how we found the services, right? How we did, yeah. Here we know what the customer want, and here we design the based on the requirement engineering perspective, and then we're going to do the system certification. We do the system certification for the specific requirement, and the system design. The system design part is trying to build. I mean, where is the detail? Where's the implement? Oh, why do you think so? I mean, is it kind of annual? Oh, so these are linked. Is it kind of and the acceptance plan? Yes. Oh, we have the acceptance test plan. Oh, from here, from the requirement. Oh, from the requirement we can see whether I met it the requirement to determine whether we accept it or not. And the system certification is the system integration test builder. Oh, and the system design part is we're going to generate a subsystem integration test plan and going to test them. Oh, interesting. And then UoL is the final part where the software is inherently flexible and can change as requirement changes through the changing of the business circumstances. The software that supports the business must also evolve and change. Also, there has been demarcation between the development and the evolution. There is an increasingly irrelevant and fewer are completely new. There is an increasingly irrelevant. This is increasingly irrelevant, and fewer systems are completely new. That is democration, development and maintenance. Oh, I see. So other other kind of development can also, based on previous development, we can see them as kind of maintenance, because development maybe is from original, and maintenance maybe just the development after development. And since the things has already been developed, and it can also be seen as development and maintenance. And it is important to realize that maintenance costs sometimes are several times of the initial development cost of the. So why do we think why it contradicts, right? It contradicts. The system evolution is that we define the system requirement and assess the existing system, and propose the system changes, modify the system, and trying to design new system, assess the existing system, modify the system, define the system. Oh. We define the system requirement, we access the existing system, and we propose the system changes, and we modify the system, and we existing system and the new system, accessing the existing system, propose system changes, modify systems, define system requirement. I understand, access the existing system, and propose system change, modify system, and define the system. Yes, an iterative one, and accessing the existing system. Yes, some kind of reviews orientated, and the proposed system changes, and we modify the system to the new system, and it also becomes a kind of like existing system. So there are two maybe dimensions here. The first is maybe from our perspective, we define system requirement, access the existing system, and propose the changes and modify the system. And after we modify the system, we are essentially building a new system and trying to incorporate the existing system to, uh, to contribute to the existing system. And after modify the system, this is how the evolution kind of iterative to come back to define system requirement. And the recap is the code reviews can be incorporated to the software engineering lifecycle using the reviews and orientated model, and the requirement engineering is the process of developing software specification, design and implementation process transform the specification to an executable program. Validation involves checking that the system meets its specification and user needs. The validation involves checking that the system meets the specification and user needs. The validation is that involving checking that the system meets the specification. Validation is user design and implement process transform the specification to an executable. Design and implement is transform the specification to executable program. And the requirement engineering is the process of developing this requirement. Engineering is the process of developing the software specification. The evolution is concerned with modifying the system after it is used. That's pretty much it. Thank you very much.